Hi, John here. Just want to do a short video today about a Pelton Turbine hydroelectric power station. So I'm on the website. I'm going to load up the model now and I can explain to you guys and girls just exactly how it works and some of the main components. So there we go. The model's loaded up. I'm just going to pause it for a moment. And what we have here is a hydroelectric power station. That's this building here. The hydroelectric power station is connected to a lower reservoir, which is the river here, and an upper reservoir, which is up here. This is this upper reservoir there. And the upper reservoir connects to the power station and the lower reservoir via a long pipe, which is this here, sometimes referred to as a penstock. So we'll go up and we'll follow the process through, and I can explain to you what's happening. If we look here, this is the intake or the main suction pipe. The suction pipe has a sluice gate or a main isolation gate. Normally you'll drop this in emergency if you want to isolate the water supply to the power station. The water is going to flow through this pipe. You can just see the end of it there. And then it is going to come out of the pipe on this side of the dam wall. Then it's going to flow down the pipe to the hydroelectric power station. We can see there's two separate pipes here because it's feeding to two separate turbines, one on the left and one on the right. If we go inside the hydroelectric power station, we can have a look at a Pelton turbine. And there we go. So we can see here there is a Pelton turbine. I took the cover off this one. Normally you wouldn't be able to see the Pelton turbine. And you can see here the water's come in. I'll just follow the pipe so you guys understand it. There's the pipe coming in. It's coming down and it's spraying out the nozzle here. Now, because the upper reservoir is so high, there is a massive weight of water or head of pressure coming out of the nozzle here. And it's hitting or impacting upon the Pelton runner or this Pelton turbine. It's landing inside these buckets here. And then the turbine is going to rotate in this direction. It's going to rotate anti-clockwise. So it's going to rotate towards the nozzle. And round and round and round. And as it rotates, it's going to drive a generator which is inside this box here. The generator is going to turn that kinetic energy, that movement, into electricity. And then once we've got that, it's relatively simple getting that then to our homes. What we're going to have here is what we call a switch gear. It's kind of like a big circuit breaker. The electricity comes out of the generator, goes to the switch gear, comes out of the switch gear, goes to a transformer, and here we're going to increase the voltage from, imagine, 6,000 volts up to 110,000 volts or 220,000 volts. It depends on your geographical location, but we're going to boost the voltage. It's going to then go through a current transformer and voltage transformer, maybe a circuit breaker, and it's going to go into the national grid, which is this here. All these poles put together, they make the national grid. And then the electricity will be transported all the way to factories and your home, etc., where you'll be able to use the electricity for useful work, such as a dryer, a washing machine, refrigerator. Just about everything we use nowadays comes from electricity, and that is how you get it. But do notice this is a Pelton turbine hydroelectric power station. It's not a Francis or a Kaplan turbine station. If you had an upper reservoir here or a very small amount of head or a small head of pressure, you would not use a Pelton turbine. The Pelton turbine is not made for low heads of pressure. So you really do need a very high upper reservoir to get that pressure, a very high pressure, and then to drive the Pelton turbine round and round. If you don't have that head of pressure, which is not possible sometimes in geographical locations where it's very flat and there's no mountains or hills, then you won't have the chance to use a Pelton turbine. But that's essentially how it works. Hope that sort of clears it up for you guys. Let's back out a second, and if you want we can load up the 3D cross-section model. Again, there's no cover on the Pelton turbine here, so we can just have a quick look at it and see some of the components. And there we go. So here is a Pelton turbine, and if we click on some of the annotations, we can learn a little bit about the Pelton turbine components. If you want, you can also take a quiz, click on the speed adjuster, and then where is that? That's a drive shaft. Okay, so now I've got a relatively low amount of points. But there's a way to do a quiz here. You can also watch a video, and hopefully you'll find that all very useful. If you really want to have a look at something else interesting, you can go through the introduction and read about the Pelton turbine itself and some of the history behind it. And hopefully by the time you've done all that, you should really understand how the Pelton turbine works and where you're likely to find it. If you want to help us out, please do like or share the video. And if you really want to support us, check out our Patreon page. Thank you very much for your time.